Hey everyone, welcome to How to Nomadify Your Kubernetes Manifests. I am super happy to have you all join me here today. If you're migrating from Kubernetes to Nomad or want to get an app that's running on Kubernetes to run on Nomad, then this talk is for you as I guide you on how to translate Kubernetes YAML manifests into Nomad HCL job specs. But before we get started, a little bit about me. My name is Adriana Villela, and I'm a HashiCorp ambassador. I also co-host the On Call Me Maybe podcast, and I love solving hard problems, whether it's my day job as a senior developer advocate at Lightstep, or on a Rockwall, which is where you'll find me blowing off steam when I'm not at work. So now that we've gotten the pleasantries out of the way, let's get started. So here's the deal. It's hard to ignore the fact that Kubernetes is super duper popular. I mean, it's so popular that most of the major public cloud providers offer some sort of managed service for spinning up and maintaining Kubernetes clusters. And that's all well and good if you're working in a Kubernetes shop or you're down for wrangling with the complexities of Kubernetes. But what if that's not the case? What if you're working in a Nomad shop or are considering making the switch from Kubernetes to Nomad? The fact is that while there are a ton of resources out there for Kubernetes land, there isn't so much out there for Nomad land, which kind of sucks, especially if you're thrust from Kubernetes land into Nomad land, which is totally what happened to me. So I actually come from a Kubernetes background, but at my last job, the orchestrator of choice was Nomad, not Kubernetes, which meant that I needed to learn me some Nomad like yesterday. And I oftentimes found myself in situations whereby I wanted to try out some cool new tool on Nomad, but all I could find were instructions on how to run it in Kubernetes. Now, not to be one to be defeated by technology, I decided to learn how to convert Kubernetes manifests into Nomad job specs. And so today I will showcase the process of that conversion using the OpenTelemetry Demo App as an example. But before we get into the conversion process, it's helpful for us to understand how Kubernetes terminology translates into Nomad terminology. So I've prepared for you a secret little decoder ring of Kubernetes to Nomad terminology. And as an aside, I do want to give a huge shout out to HashiCorp, which put together a really, really amazing guide on how to go from Kubernetes to Nomad called A Kubernetes User's Guide to HashiCorp Nomad. And I promise I'll include a link to that at the end of these slides. So this was the basis for my own work on Nomad. I highly recommend that you check out this blog post. So let's look at our secret decoder ring. So in Kubernetes, we've got a container runtime. In Nomad, we have a task driver because guess what? In Nomad, you can run more than just containerized workloads. You can run virtualized workloads, you can run JVMs, IaaS, etc. In Kubernetes, which we have a pod, which is our smallest deployable unit. And in Nomad, we have a task group. In Kubernetes, we have a container, which runs inside a pod. In Nomad, we have a task, which runs inside a task group. And that's the smallest deployable unit. In Kubernetes, we have a manifest. In Nomad, we have a job spec. In Kubernetes, we refer to Kubernetes deployments. In Nomad, we refer to Nomad jobs. And then we have services for Kubernetes and Nomad. Now, for those who are more visual learners, there's a nice little visualization of what I mentioned, also courtesy of that wonderful HashiCorp blog post that I mentioned earlier. So now that we've established some common language, let's dig into the conversion process. In order to convert a Kubernetes manifest into Nomad, you need to do the following. Well, first, you need to start out with the Kubernetes manifest that you'll be converting. Next, you need a job spec template, which is where you'll plug the data from your Kubernetes manifest into. And within that job spec, you'll need to fill in some of the blanks from the Kubernetes manifest. And that includes defining ports, defining services, and defining your task. And that in itself includes configuring container images, defining your environment variables, restart rules, and resource allocation, all of which I will cover shortly. Now, as I mentioned earlier, I will be demonstrating all of this using an example from the OpenTelemetry Demo App. Now, for a little bit of background, OpenTelemetry, or OTel, is an open source, vendor-neutral framework for instrumenting, generating, collecting, and exporting telemetry data. The OpenTelemetry Demo App is made up of multiple microservices written in a number of different languages, including Go, Python, Java, JavaScript.NET, Rust, and more. And the services emit traces and metrics using OpenTelemetry. Now, the process of converting the Kubernetes manifest for each of these services is actually into the corresponding Nomad job spec is actually pretty similar. So in the interest of not boring y'all to death today, I'll be choosing one service to illustrate this conversion, which is the feature flag service. So let's start with our Kubernetes manifest. Now, fortunately, we can grab this easily from the OTel Helm Charts repo, which I had the QR code for in the previous slide. I have a reference link to that as well at the end of these slides. For the purposes of our example, we need to grab two key pieces of information for the feature flag service. One is the Kubernetes deployment definition, and then we have the service definition. Now, with our Kubernetes manifest in hand, we can start prepping our Nomad job spec. So let's start with a basic Nomad job spec like the one that you see here. This will serve as a template for deploying our application to Nomad. Now, bear in mind that this is a starting point for our conversation. After all, some of the services in the OTel Demo App are more complex than others. So for some services, we might need all the components to be included in our job spec. For other services, we might end up with a more pared down version of the job spec. So with our job spec in hand, let's start to fill out some blanks. Since we know that we're working with a feature flag service, I've gone ahead and replaced service name with feature flag service. And honestly, you can call this anything you want as long as the name is meaningful and descriptive. So now it means that our template looks like this. So the next set of blanks that we need to fill in are in the network stanza, and more specifically, the port name and also the port number. Now, if we look at our feature flag service YAML, you'll notice that it actually exposes two ports. We have port 50053, which is a gRPC port, and port 8081, which is an HTTP port. So we'll plug these into our lovely job spec. So now that we've defined our ports, we need to register our services, which is done by way of the service stanza. So again, we have two ports, so it means that we need to define two services, one per port. So one service for the HTTP port and one for the gRPC port. Now let's look at the HTTP service first. The service is called feature flag service HTTP. Now you can call it whatever you want, though again, a descriptive name is always helpful. By default, the service is registered to Consul. And for those unfamiliar with Consul, it's a service discovery and configuration tool, plays super nice with Nomad. You'll hear a little bit more about Consul later. Now, even though we don't actually say it directly here that we're registering the service to Consul, we are basically implying this. So adding provider equals Consul, that's equivalent. If you wanted to register to a different provider, i.e. Nomad, you would replace provider equals Consul with provider equals Nomad. All right, so the next thing we have is the port attribute. So it's pointing to the network port label that we defined earlier in the network stanza. So our port label is HTTP, and we're saying in our service stanza, we are pointing to a port named HTTP, which refers to our lovely port 8081. Another thing that we're doing is exposing the service to the outside world. And in order to do this, I have chosen Traefik as the load balancer. This actually means that you have to run a Traefik job in Nomad. So we have to do this by deploying a Traefik job spec. And in addition to that, we also need to configure our feature flag service to work with Traefik. So that includes adding these Traefik specific tags in our service stanza. And as you can see here, one of the things that we do is expose the service to the outside world. So it's accessible through the URL feature.localhost. In my case, I'm running this locally on my machine. So it's available through feature.localhost. And finally, we configure the check stanza. Now this runs a health check on the service, and since the service is registered to Consul, the health check runs on Consul itself. The above health check is configured to run every 10 seconds and is given 5 seconds for the health check query to succeed. Now the health check in Nomad is similar to a Kubernetes liveness probe. Now we move on to the gRPC service. Since we're not exposing any outside services, we don't need the tags attribute with the Traefik configuration, so that simplifies things. The port attribute refers to the gRPC port that we defined earlier in the network stanza. And we are doing the same health check that we did with the HTTP port. As a little aside, as far as health checks go, you can do different types of health checks. Here we're doing a TCP health check, but you can also do a gRPC health check, and you can even do a health check based on running a script. So for example, if you were deploying a Postgres job spec, you could actually run a health check that runs the PG is ready command line tool. So things to keep in mind there. So now we're ready to define our task. Since we're running a containerized workload, our task uses the Docker driver. And since we're using the Docker driver, we need to provide the following information to Nomad via the config stanza. So first of all, we need to specify our Docker image. And as you can see, we get the information on the Docker image from our Kubernetes manifest in our spec configuration, in our spec container configuration. Another thing that we do is we configure this image pull timeout value. Now, by default, if you leave this out, it defaults to 5 minutes. In my case, I typically like to put a higher value than that. This is purely optional, but I like to use a high value because sometimes you just never know if your network decides to act all slow. And personally, I don't want my job spec to fail to deploy because it wasn't able to pull an image from a container registry. Next, we have the ports being used by the Docker image. So we see in our Kubernetes manifest that the container image uses both our gRPC and HTTP ports. So we specify that in our task configuration. So in a nutshell, this section of our deployment YAML corresponds to this section of our Nomad job spec, HCL. Now, we're not done quite yet with configuring our feature flag service task. If you look at the deployment YAML, you'll notice that there are a number of environment variables under the env tag. That's a lot of environment variables, but you can actually ignore the ones that start with OTEL-K8 because they are Kubernetes specific. However, we do care about these environment variables. So it's worth mentioning a few noteworthy items. First of all, let us look at the feature flag gRPC service port environment variable. As you can see here, its value is Nomad port gRPC and not 50053. Now we could totally use 50053 if we wanted to, but if that port number changes, then we're on the hook to change that value everywhere else that uses it. So instead we use this funny Nomad port gRPC notation, which is actually a runtime environment variable. And it follows this naming convention, which is Nomad port label. In this case, our port is called gRPC, so the Nomad port label is Nomad port gRPC. And we see a similar case with our feature flag service port, which is called Nomad port HTTP. So now let's turn our attention back to our Kubernetes YAML. Now you'll notice that we've got our OTEL resource attributes environment variable, and it's set to this big garble of text. But if you look closely, most of these attributes are Kubernetes related, so we don't actually need all of them, obviously, because we are using Nomad. So instead, the only piece of information that I want to take is this service name equals OTEL service name equals feature flag service, OTEL service name equals feature flag service. But we are not done yet with our environment variable configuration, because if you look at the Kubernetes manifest environment variables compared to the Nomad job spec environment variables, you'll notice two of them are missing from our job spec. So the question is, why are they missing? The short answer is they're not. The long answer is we need to place them somewhere else. But before we understand that, we need to go back to our Kubernetes manifest. So these are the missing environment variables. All right, so if you look at the deployment YAML, you'll notice that the value for database URL is this lovely address that we see here. And then we have the OTel exporter OTLP endpoint environment variable, which points to this other lovely address. But while this and this might make perfect sense to Kubernetes, they do not make a heck of a lot of sense to Nomad. So if we try to use those same names in our job spec definition, you'll get a big old nasty error from Nomad. So the question is, how do we get our services to talk to each other in Nomad? Now, we could hard code the IP addresses of these services, but that's not such a great idea because IP addresses are bound to change. So if and when they change, the job spec will fail to deploy. What we need is a way to dynamically get a service's IP address given the service's name. And this is where our good friend Consul comes in. And among other things, Consul offers service discovery, which is exactly what we need. But first, let's take a little step back. So as you can see in this snippet of our environment variable definition, we have our two environment variables, which point to two different services. So first we have our Postgres service, and then we have our OTel collector service. Now, assuming that for our conversion process for the OTel demo app, we are converting the job specs for every service, we would then have job specs not only for the feature flag service, but we would also have job specs with service definitions for our Postgres service. And we would also have job spec definitions for our OTel collector service. And this is important because in doing so, we register them to Consul, right, as part of our service definition. So if you open up the Consul UI, you will see the OTel collector gRPC service and the Postgres service registered in Consul, which is all well and good. But you might be wondering, okay, we've got a means of dynamically getting a service's IP, but what exactly does that look like in our job spec? And that is a most excellent question. And the answer to that question can be found here in the Nomad template stanza. Now, the Nomad template stanza is very reminiscent of a Kubernetes config map. Per the Nomad docs, the template lets you ship configuration files that are populated from environment variables, Consul data, vault secrets, or just general configurations with any Nomad task. And in our case, we're using a template to query Consul services so that we can find the IP address and port number of these services so we can populate our two remaining environment variables, our database URL and our OTLP exporter endpoint. So going back to our Nomad job spec, let's look at how to configure our two environment variables in the template stanza. So the template stanza is defined inside our task stanza. And within the template stanza, you might notice two configurations. First, we have this lovely attribute, destination equals local env. Now, this value can technically be anything. It is basically a label. And then we have another value, another attribute, which is env equals true, which tells Nomad to export values in the stanza as environment variables made available to our container at runtime. So next we look at the actual environment variable definition. So let's start with our database environment variable. Now, this line here tells Nomad to look for a service in Consul called FFS Postgres service, which, as you may recall, was defined in our Postgres job spec. Now, once it finds a service name, we can pull the service's IP address and port number using special curly braces notation. So double curly braces dot address gives us the IP address, and double curly braces dot port gives us the port number. And we see a similar deal with our traces endpoint environment variable. So now that we've got the environment variable sorted out, let's talk a little bit about restart rules. Now, unlike Docker Compose, you can't simply specify service dependencies in Nomad. And if you work with Kubernetes, the same goes for Kubernetes. So in order to ensure that service X doesn't die on you because it's dependent on service Y, which hasn't started yet, you can put a restart policy into place. And here is the restart policy that I configured for the feature flag service. So here we have restart policy that states that Nomad will try to restart the job 10 times in the span of 2 minutes. and it will wait 15 seconds between restarts. Now, if after 10 attempts at a restart, by default, the job hasn't started successfully, Nomad will fail the deployment and the job will be dead. And this is dictated by the mode attribute, which defaults to fail. But as I mentioned, that is not at all what we want to happen. So instead, we have to set our mode to delay. And this tells Nomad to restart the job another 10 times. And this cycle goes on and on and on until the job finally restarts successfully. And finally, we've reached our last bit of configuration for our task and our final topic of discussion, resource allocations. Now, resource allocations are important because they tell Nomad how much of Nomad's total memory and CPU should be allotted to your job spec. Now, resource allocations are defined in the task stanza and look like this. So first, let's look at CPU allocation. CPU allocation is measured in megahertz, and in this case, we've allocated 55 megahertz of CPU to this job spec. Next, we have memory allocation. Memory allocation is measured in mebibytes, and as an aside, a mebibyte is 1,024 bytes, whereas a megabyte is 1,000 bytes. Now, you might be wondering, that's all well and good, but how the heck did I decide what values to use? And the answer is, I had to do a little bit of playing around. And to help me out, I went to this lovely Nomad topology screen. Now, this screen is actually super handy. Here I can see that it tells me my overall memory available on Nomad. And as you can see, I'm working with a total of 9.28 gigs in my instance. So I need to ensure that all combined, all of my job specs don't exceed that. And I can also see how much CPU I have available on Nomad. And in this case, I'm working with 2 gigahertz of total CPU. So again, I need to make sure that all combined, my job specs don't exceed that. And to help with that, there's also an additional little visualization here that shows how much memory and CPU each of your jobs is using up. Now, this is definitely a super helpful screen, but another thing that really helps me in determining allocations is actually going to the job allocation screen after the job has been deployed to Nomad. So one trick that I like to use is sometimes I will deploy a job with no memory or CPU set, so no resource allocations. And that means that Nomad picks those values. And then I go into this allocation screen and see how much Nomad has allocated to me. And also of that amount that's been allocated, how much has been used. So we can see here the amount used versus allocated for our CPU and the amount used versus allocated for our memory. And if I find, okay, well, it looks like the amount of memory that has been allocated is way higher compared to the amount of memory actually being consumed, then I will go in and tweak those values. So I use those as, I use the default, the chosen Nomad values as a starting point, and then I'll go and tweak those values as needed. And that is basically it for resource allocations. So there we have it. That is what we need to define our job spec. So to summarize, we started with our job spec template. And in our job spec template, we defined our ports, our services, and our task. Within our task, we also configured our container. We configured our environment variables, some of which we needed to utilize Consul templating, configured restart rules, and finally, our resource allocations. And this led to our final job spec, which looks like this. Hooray! So there you have it. I know that's been a lot to take in, a lot of information. And whenever I write lengthy blog posts, especially the technical ones, I do like to reward my blog readers with cute little pictures of my pet rats, which is what I will do right now. These are my pet rats, Bunny on the left and Phoebe on the right. Phoebe was named after the Friends character. Thank you so much for sticking around. Be sure to check out the OpenTelemetry Demo App on GitHub. The OpenTelemetry project is always looking for contributions, whether it's through code, user stories of OTel in real life, docs updates, blog posts. Also, be sure to check out my Nomad conversions repo on GitHub to see some of the Nomad job specs that I've converted from Kubernetes. These include the OTel Demo App, Trace Test, and Temporal. And I've also included, as I said earlier, a link to that really great Hashi post, a Kubernetes user's guide to Nomad. And finally, I would like to acknowledge our lovely AI friend, Dolly, for helping me generate some of the fun, whimsical images that you have seen in this slideshow. If you have any questions or would like to talk more about any of the topics that I covered today, please hit me up on any of the socials. Until next time, peace, love, and code.